Hi, my name is Brian Delurier, and this is my presentation for Lab 2 for Physics 2212 of charged tapes. So the experiment that we're going to be doing today is the same as Lab 1. So this experiment will calculate the charge contained on one piece of charged clear tape and the forces acting on a charged tape if another isn't introduced, creating the scene shown in the top right corner. The purpose of Lab 2 will be to continue the ideas from Lab 1 with a more complicated model to obtain a more accurate estimate of the charge and electric force on the U-tape. The procedure is the same as Lab 1. So in order to create the charge on the tape, place a piece of tape down on the table. You will then place a second tape on top and pull the two tapes apart. The top tape, or U-tape, should now be positively charged. This process can be repeated to create multiple pieces of charged tape. So some of the fundamental concepts that we'll be using today are Coulomb's law, which is shown on the right with F equals KQQ over R squared. Superposition, where we use several different point charge estimations along the piece of tape to model the electric field for the entire piece of tape. And then Newton's second and third laws, where force is equal to mass times acceleration. We will use this for the force of gravity on the tape. And then if two bodies exert a force on one another, the forces are equal and opposite. So we will use that as to why the two tapes repel as well. So some of the models and assumptions that we'll be using. So the model shown to the right is what I created in GlowScript, and it shows the forces acting on the two pieces of charged tape. Well, particularly the U-tape or upper tape. It is expected that the two pieces of tape should repel as they have the same positive charge. Gravity is also acting on the floating tape, or the one in red on the top, creating a net zero force on the piece of tape, which is why it will float. The green arrows show the charge on the top tape. The white arrow shows the force of the bottom tape on the top tape. And the yellow arrow shows the force of gravity on the top tape. And you can see that the white and yellow arrows are equal. Some assumptions that I made is 1, air resistance is ignored. 2, the U-tape can be divided into many segments with the charge evenly distributed on the tape, or DQ, as you will see later in the GlowScript code. And then due to superposition, the sum of the individual charges will be equal to the total charge on the U-tape. So to recap Lab 1, the measurements that I got was the length of the tape is 0.2 meters, the mass is 0.002 kilograms, distance between the tapes is 0.033 meters. Gravitational force comes out to 1.962 times 10 to the negative 3 newtons. And the charge on the tape is found by setting that gravitational force equal to the opposite of the force of the electric field. And with this, you get Q is equal to 1.5408 times 10 to the negative 8 coulombs. GlowScript code I used, that top one, creates an electric field from the tape. As you can see, we just go through and plug in all of our values into the electric field equation from Coulomb's law. Second one creates a line of charge. So essentially it is creating a bunch of points. As you can see in the model, those red and blue dots that show the tape. Moving on, the rest of this code is creating is showing how we compare the DQ, or small little point charges that we use along the tape to create a line of charge. And basically through this code we are iterating through each DQ until we get a net electric force for the entire charge, for the entire tape, and this is equal to the total charge. In conclusion, what if I had modeled each of my tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So I got 1.5408 times 10 to the negative 8 coulombs in this lab versus 2.924 times 10 to the negative 8 in the previous lab. This is about a 62% difference, which is pretty large. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? The method of calculation between Lab 1 and Lab 2 is different. i.e. 1 point charge was used to estimate in lab 1 versus the many point charges that were used in this lab across the tape. And therefore, the line charge model from lab 2 is more accurate as it more accurately models the real-life phenomena of electric force across a piece of tape. If you would like to see my GlowScript code, you can view it here. And it'll also be in the description in this video. Thank you.